Here's another example that applies the centroid theorem, that same theorem that the segment's getting divided into 2/3 and 1/3. In triangle LMN, PY is 7. PY, that's this one right here. Find LP. Because LX is congruent to XM, and X is the midpoint of side LM, and NX, right here, is the median of triangle LMN. Likewise, Y and a Z are midpoints of MN and LN, respectively. So LY and MZ are also medians of triangle LMN. Therefore, point P is the centroid of LMN. Now, given all of that information, we know that P is the centroid. So we know that LP is 2/3 of LY and PY is 1/3 of LY. So we're going to change LY to the segment addition of LP plus PY, right? So we just substituted LY into LP plus PY because it's the same thing, because we know that LP plus PY has to be LY. We know that PY is 7, so we're going to substitute 7 in for PY. We distribute the 2/3, and we're going to leave this as a fraction because it's easier to work with in this case because of the 2/3 already in here. We subtract 2/3 from both sides. So if you have a whole LP and you take 2/3 of an LP away, you have 1/3 of the LP left. Then to get rid of the 1/3, you can either divide by 1/3 or multiply by the reciprocal, which is 3 or 3/1, either way. So that means that LP is 14. One thing you might have noticed is that the smaller section and the larger section, the smaller section is half of the larger section is twice the smaller section. That might be something that you can keep in mind when you're doing this. So when the numbers are small and easy to work with, you can just do it in your head without having to go through all of these steps.